Hello, today we are going to talk about exponents. Okay, so you may have seen exponents, but if you haven't, it looks something like this, where we say 2 raised to the third power. And all this means is we take the number 1 and we multiply it by 2 3 times. So we'd have 1 times 2 times, there we go, times 2 times 2. And that gives us 8. So 2 raised to the third power is 8. Now, some terms. Okay, this number here, this 2, is what we call the base. It's the number that we're multiplying by. So you can see we're multiplying by 2. The number of times we multiply the base by is this number 3 here, and that is called our exponent. Okay. This whole thing is called a power. So we have 2 raised to the 3 is a power, 2 to the third power. This whole process we refer to as exponentiation. The same way when we talk about multiplication, we're talking about multiplying numbers, and when we're talking about addition, we're talking about adding numbers. This is called exponentiation. So let's just go through a few examples. So we have 2 raised to the third power. Well, how about 3 raised to the second power? Another way of referring to something raised to the second power is saying that number squared. So this would be 3 squared. Well, let's expand it out and get 1 times the base 3 times 3, which gives us 9. How about 2 raised to the 5th power, slightly larger exponent? Well, that is 1 times 2 times 2 times 2 times 2 times 2, which gives us 2, 4, 8, 16, 32. Okay, so again, in this example, 2 is our base, 5 is our exponent. This whole thing is a power, and this whole process is called exponentiation. Okay. So, what happens, how about as another example, what happens when we say 6 raised to the 1 power? Well, that would be 1 times 6. And we only have 1 6 here. So that becomes 6. And we can generalize this to saying any base raised to the 1 power is just going to give us that base back. So again, 3 raised to the 1 is going to give us 1 times 3, which is just going to give us 3. 7 to the 1 is just going to give us 7. We can skip writing that out. You get the idea. Okay, so far so good. Now, how about when we raise something to the 0 power? So how about 4 raised to the 0? Well, again, we say multiply 1, but now we're not multiplying by any number of bases. We're multiplying 1 times the base 0 times, right? 4, we're not multiplying by 4 at all here, 0 times. So we just have 1. And same thing here, 5 times 0. Well, that's just 1. We're not multiplying by 5 any number of times, or 0 number of times. We'll do one more, so 6 raised to the 0 is just, 6 raised to the 0 is just 1. And we can generalize this to say any base raised to the 0 power is just going to give us 1 every time. Okay, so now we've talked about raising to the 1 power, raising to the 0 power. What about when we raise to a negative power? Well, to answer that question, I want to draw a comparison to multiplication. Scroll down just a little more. When I say 3 times 4, this is going to be equivalent to 0 plus 3 plus 3 plus 3 plus 3. So 3 times 4 means we're adding 3 4 times. And that's going to give us 12. Okay, so this is addition. Okay, but what happens when I say 3 times negative 4? Well, instead of adding 3 4 times, we're going to subtract 3 4 times. So this is the same as saying 0 minus 3 minus 3 minus 3 minus 3. And that's going to give us negative 12. And this is subtraction when we have a negative number and we're multiplying. Okay, so keeping that in mind, let's talk about what happens when we have negative exponents. So if I say 2 raised to the 3rd power, again, that's 1 times 2 times 2 times 2, which gives us 8. Well, so in this case, we're multiplying by the base 3 times. Well, what happens when I have 2 raised to the negative 3 power? Well, similarly to the way we subtract when we're multiplying by a negative number, when we raise to a negative exponent, we do the opposite of multiply, or the inverse of multiplication, which is division. So we say 1 divided by 2 divided by 2 divided by 2, which gives us 1 over 8. These two numbers here are called inverses. So you'll notice that 2 raised to the 3rd power multiplied by 2 raised to the negative 3 power is going to give us 1. We can generalize negative exponents saying any base raised to a negative exponent n is going to be 1 over that base raised to the positive n. Okay, so let's do a few examples. If I have 3 raised to the negative 3, well, let's see, that's 1 divided by 3 divided by 3 divided by 3. Okay, and dividing by a number is the same thing as multiplying by the inverse. So that just means I have 1 times 1/3 times 1/3 times 1/3. Okay, and well, that is like saying 1 times 1 over 3 times 3 times 3, which is equivalent to saying 1 times 1 over 3 to the 3rd. So that is saying 1 times 1 over 27, or just 1 over 27. So again, 3 raised to the negative 3rd is equal to 1 over 3 raised to the 3, which equals 1 over 27 as our answer. So just to reiterate, a positive exponent means you multiply by the base that number of times, and a negative exponent means you divide by that base the n number of times. And you can actually see that the pattern makes a lot of sense when I start to write out some exponents. So I'll use the base 2 as an example. So if I have, say, 2 raised to the 4th, well, that gives me 16. If I have 2 raised to the 3rd, that's going to give me 8. 2 squared, or 2 raised to the 2, it's going to give me 4. 2 raised to the 1, it's going to give me 2. 2 raised to the 0, it's going to give me 1. Okay, so you can see every time we decrease the exponent by 1, we're dividing by 2. So what would 2 to the negative 1 be? Well, following the pattern, we take 1 and we divide it by 2. So we end up with 1/2. 2 raised to the negative 2. Again, we divide 1/2 by 2 and we get 1/4. And so on and so on. 2 raised to the negative 3 gives me 1/8. Okay, so hopefully that makes it clear when we're dealing with exponents, specifically integer exponents. That makes it clear what happens when n is greater than 1, n equals 1, n equals 0, and n is less than 0. So these are the cases that we've talked about where n is an integer. Okay. In future videos, we're going to talk about what happens when n is a fraction. We have fractional exponents. Oops. Well, that's a future video. We're also going to talk about how we can graphing exponential functions. We can talk about what happens when we have negative bases. And finally, we can talk about some word problems. Oh, and I haven't even mentioned, but there are certain rules that govern exponents. That would be the laws of exponents, which really come in handy when you're trying to simplify exponential expressions. And simplification. Okay, well, thank you so much for watching, and stay tuned for more videos on exponents.